So here we are at the composite figures and probability lesson, and we have two goals, two objectives, to be able to find the perimeter and the area of composite figures. Composite figures are some sort of strange figure that is composed of smaller, more basic shapes that we could name, like, oh, it's got triangles and rectangles and squares in it. Number two, we will use lengths and areas to find geometric probabilities. And probability, you've probably discussed in another math class, is about how likely it is that something is going to happen, and we're going to tie it to lengths and areas. The assignment, there will be a composite figures worksheet separately from some geometric probability practice problems. So let's take a look at that warm-up question that you started with. What is the perimeter and the area of this polygon? Well, it is in fact a polygon, even if it is a strange one, because it's completely enclosed, it's flat, and it's all straight sides. Well, since this thing is graphed, one of the ways that you can find its area is just simply counting up all of the squares, right? But I'm not going to do that because I know from, say, multiplication, when I learned to multiply, if I wanted to know how many squares were in that rectangle, I can just take its length and its width and just multiply it, right? So this is two blocks high, and this is 1, 2, 3, 4, 5, 5. So this is a total of 10 units squared so far. And then I could do a trapezoid on both the top and the bottom here, or just go look at each one of these squares. Whoops, look at each one of these squares here. So that would make 11. That one would make 12. And then what do I do with the triangles? Well, imagine just getting rid of that triangle and putting it over here, and that would make 13. And then likewise getting rid of this triangle and then translating and rotating and stuff and putting it right there to make 14, which means that our area here is equal to exactly 14 units squared. I'm using the generic unit squared or u squared because it's just on a graph grid and nothing else was specified. I think this deserves an orange box. All right, the second part of this question is asking us for the perimeter. So when we defined perimeter, we just said it was the distance around the shape. If it's a polygon, you just add up all of the side lengths. Okay, so that should be pretty easy because all of these sides are just straight segments. I'm going to start with all of the vertical and horizontal ones because those are the ones that are easiest to count up, right? So on both the left and the right side, we have 2 and a 2. And then all of the horizontal pieces, each one of these is 1, right? Okay, I can do that. 1, 1, 1, nope. 1, 1, 1, and 1. And what I'm left with here are the diagonal pieces. That diagonal piece that I just traced off right there, is it 1? Is it also 1 just like this one is, or just like this one is? It actually can't be. And the reason why it can't be is because it forms a right triangle. So let me just trace off a right triangle here. And you can notice that the slanted side is the hypotenuse of that right triangle, and we know that the hypotenuse is always supposed to be the longer segment in any right triangle. So in order to figure out how long that is, I'll just use the Pythagorean Theorem. Let's throw a right angle in there. That side's 1. This side over here is 1, and we will just call this length c and use the Pythagorean Theorem on it. Go c squared is equal to 1 squared plus 1 squared. 1 squared is 1, and I've got 2 of them, so c squared is equal to 2. And always the last step here is to take the square root. As we've talked about before, when I take the square root, I should have 2 answers, a positive and a negative, but a negative length for that segment doesn't make any sense. So we're just going to choose the positive one. So I'm going to get rid of that c, and all of the slanted sides, I'm going to put a square root of 2. Okay, so now I'm ready to find the perimeter. I'm going to add up all the whole numbers first. So I've got here and here, that's a total of 4. I've got 3 on the top and 3 on the bottom. That's 6 for a total of 10. So as far as the whole numbers go, we have 10 plus, and now all the slanted sides, each one of those is a square root of 2. And I have a total of 4 of them. Think of this as like an x. That's an x, and then I have 4 times x. I'm going to write it in the same kind of way. 4 square root of 2. units. And this is the exact form of this answer, the exact length. Different from an approximation that I would get by putting this into the calculator. And the reason why there is a big difference is the fact that the square root of 2 is an irrational number. As soon as you put it into the calculator, those decimals, they go on and on forever, even if you only see about 9 or 10 of them. Let's go ahead and put it into the calculator so that we can approximate it. So I'll pull up a calculator app. And it was 10 plus the square root of, no, whoa, back that up. It was 4 square root of 2. And then we'll hit enter on that one. And you can see over here that we've got 15.6568, blah, blah, blah. And again, those decimals are supposed to go on and on forever. And unlike something like this, if I put 9 divided by, let's say, 6 into the calculator, I have 1.5, but I also have the possibility of turning that into a fraction. And you don't have that option on the number right up above it, that irrational number. So you can see right here on the screen as we see it, on the left side, 10 plus 4 square root of 2 is the exact form of that answer. And the 15.66, if I round it to 2 decimal places, is the approximate answer. Let's write that one down also. So I will say that the perimeter, where is my blue crayon? Perimeter is approximately equal, with 2 squiggly marks, 15.66, I think, when we chose 2 decimal places. And again, this one is the approximate answer. Anytime that we're dealing with irrational numbers, if the problem doesn't specify which one to use, you do have your option of writing either an exact or an approximate. The advantage of an exact answer here, at no point did I actually have to use a calculator. Like, I could stop right here and it's a perfectly acceptable answer. Not only that, it contains more information. It's more accurate than this one because we had to chop off and round that hundredths decimal place.